So what do we look at here? We have now the chip with the display. So far we haven't used the display. This is what we try to do now in this tutorial. So what do we need for that? We need a library that can talk to the display. It's an I2C display, and I just brought a very similar display. This is a very similar display, and we can later try to connect this to another chip. So this is the display which is fixed mounted here. There is also a similar chip, like we have the ESP32 and there is another one of those in a different form factor, also with a display. So some of them come with displays, and we try now to connect the display. What do we need to connect the display? We need the library, and in our case, this is called ssd1306. That's the library for this display, and I have a file called display test, which we can use. So what do we need? We first need to connect our device to the IDE, and I do this, I just plug it in here. Let's see what happens. So I've plugged it in, and now let's see if we can see it on the serial line. Oh yes, it's COM4, and here we are. And let's try print hello. So we're now connected to the chip. It's working. Now, what do we need? We need to get the libraries onto the chip. So what I do is I put this one on, it's uploading it, and I put display test on as well. And now let's have a look. So we have a number of files here. We always have the boot file here, and from our last exercise we still have the LED one on, but here now let's open this one. This is the library, and we don't go into details. This is the library that really talks to the display, and you can see there are different functions. But what's interesting for us is the thing that's called display test, and I've written this. And now let's move to the other screen. So now I put this just into focus that we can see if something is happening here. Okay, so what we see here, we walk through. So we import I2C. I2C is a bus. It's used to add components like sensors, like displays, like actuators to the chip. And it's a protocol that runs over 2 pins, and one is clock and one is data. And we see this here. We need to name them later. So we have to import I2C. We also need pin, and we also need to import the library that talks to the display. And then what do? We set the display size, the width and the height. How do we know that? That's in the data sheet of the chip or the display. And once we have the I2C connection, this is really the variable in which we hold how it's connected to the chip. And once we have this and the size of the display, we can start to connect it. Let's do this manually here that we can see how it works. So I copy this down here. So okay, so we import this, and now we import the whole library for the display. This is ssd1306. Now we have all the libraries imported. Now we define our I2C bus connection, which is this one. Does not really work, so the keyboard shortcuts don't work for me, but now I have a variable. Now I define the display size. And this was how wide it is, and this is how high it is. So far, we only set variables with the information. What we do now is now we set up the display. Let's do that. And now we have the display, and now we can start working with this display. And what I have here is I can do OLED, that's my variable, and I just do text. And text has 3 parameters. The first parameter is a string, so I say hello LMU. And the second parameter is where it starts on the width. And third parameter, so we say 0, so we start at the very front of the display, and we start at the very top of the display. So let's see if we see something on the display. Now we have a look at the display. We see nothing. This is as we expect, because we also have to call OLED show. So I can do this already now. And now let's have a look at the display. And now we can see this, and I go closer with the other camera. So now we see this says hello LMU, what I just put on there. Now let's get back to my programming window, and now we can write another text. Let's go here. I can go to pixel 10, and I can, let's say, write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, we don't see anything, but once I do show, we can see it shows up. So it's important to remember, you have to put the text out, but you also have to call show, otherwise it doesn't show up. And with this, we know how to use the display. So again, the important steps: you have to copy the ssd1306.py. This is the library. You have to copy it onto the chip, and then you have to call, you have to import the modules, and you have to set up the I2C bus, the size of the display. You then initialize the display, and then you can write on it. But before you see it, you have to call show. And with this, we could now, for example, add a sensor. And what I do is I create a new file, and I copy over stuff of here, and we try to make a very simple thing where we show something on there. So let's connect. I've got here a knob, and I think you remember we have connected analog to digital. So what I do is I put this to one of the analog pins. So I get the example for analog up first, and then we look how to connect that. So let's go to micropython.org, go to the doc, and now let's have a look. Quick reference for the ESP32. We have a look at analog digital conversion. And if you remember, that's what we need. So I copy this one into the head of my file. So I import the analog digital conversion. And what I have here, I set up pin 32, and we have pin 32 on this side. So I put this one into pin 32. That's the middle of the POTI. Oops, let's get this in here. And I add this to 3 volts and this to 0 volt. So now I can read in the analog input. So I put this again into the head of the file. So I put, so we have set this up. And now we do a loop where we read and write on the display. Okay. So what do? We have to also set these. We want to have the full length. So we don't do the 9-bit. We want to have the 12-bit, but I want to have the full range. Otherwise, I'm not getting the full range of the potentiometer. We discussed this shortly in the analog tutorial. So what I do now is I do a loop while true, and we do a loop where we read in the analog value. And how do we do that? This is ADC read, and we have to assign it to a variable. So I say V for voltage is my variable is ADC dot read, and I read this in. And now what I do, I print it on the console that we can see it here, but also on the screen. Print V, and I also put it on the display. Now let's have another look how this is. So we just copy this one over. So now let's see what happens if I put a non-string variable in there. I haven't tried it, so let's see what happens. And then we do sleep for 1 second, and then we read it again. Okay, so in order to use sleep, we need to import also sleep from time. Okay, so we have now this. And now let's see what happens. This may be not working, or it may be working. So we have to see if this does a conversion from the value we read. This is a float, like a number, and we'll see if this works. So let's see what happens. Now, what do? We have to put it down onto the chip. Let's do that. And I have to save it before, so I'll do that. Save as, and I call it test ADC because it's sort of on the display. So let's try this. And I have it here. So what I do is I close it here and I reopen it. I copy it down to the chip, and okay, we have it now here. I open it, and okay, so we have an error. What is not working? So in line 28, and this is as expected, we have a variable that's a float and we need a string. So what do? We have a look how to convert in MicroPython float to string. And now let's have a look. This is Python, but we want to have MicroPython because there may be a difference. So let's have a look here anyway and see. So let's see if we can get the string function. Let's see if this works. And now what we see, it prints it out, and it doesn't print it on the screen. What did we forget? We forgot to add show. So let's do that. So if you look here in display text, this was sort of the last command. So let's save it and let's try again. So what do we see here? We see the value on here, and if I'm now changing, I try to get this a bit more in focus. Let's try this here. Okay, now I have this here. And what do I see? I don't see much, and I think you can see it. If I change here, we're not clearing the display. So we are just clocking up the display. If you look at the other values, they look good, but here it doesn't look good. Okay, so we have to look how to clear the display. Okay, so how do we do this? Let's have a look at the library. So if there is a function that clears it up. And how can we do this? I stop the program here. So there's a function which is called help, and we can call, So I think we first have to do it here, import ssd1306, and now I can do help ssd1306. Now we get all the functions that are available, and so we get sort of a lot of functions that were used. But I think from this we don't really find how it's going to work. So let's just have a look how we can do it. Okay, so how do we clear the screen? Now here there is some discussion how to do that. Okay, and now sort of they do the same thing. They use different pins, and basically they use the function fill, and then they draw on it. So let's see if we can use that to do what we want. Let's see. So let's go in here. See what happens here, and we do a OLED show in between. So let's try what we see here. And so what we see is it fills it, and if I turn here, we can see we're not overwriting it. Let me get this closer in here. So what we see here, I see the number, and if I turn, we can see the value. It's the same value that's on the console. So, and you can also see it flickering a little bit, but it's not perfect on the camera, but it flickers because each time we basically clear the screen before we draw something else. We could probably start now thinking how we optimize that we only clean certain screen area. But with this, we have a sensor connected to the display, and we can already see what's on the display. Now let's quickly go through the program again. So this is our program. We need ADC to read in the analog digital value. We need the sleep function in order to not be sort of printing all the time and clocking up the processor. We need machine for the I2C bus. This is sort of the connection where the display is on. And we need pin because that's used for defining which pin is used in the bus. And we need the module ssd1306, which is the module where all the functions are in, which drive the display. So here we set up the I2C bus. It's the clock is on pin 15, the data is on pin 4. And how do we know that? Let's have a quick look. So we go to the Heltec site where we were before. We look into the documentation. And now if we look at the documentation, we can see there is the display connected. And what you see here is the display is connected to pin 15, which is clock, and pin 4, which is data. And this is what we have here, pin 15 for clock and pin 4 for data. Then the size of the display, that's also in the data sheet. So let's see if we can see it here directly. So does it say somewhere how big the display is? The text spec. So the display size is a 96-inch OLED. It doesn't really say here the pixels. So if we let's see, send the frequently asked questions, and if not, it's not in here. So let's Google and this is also a display we can get separately. And now let's have a look. Here it is, 128 by 64, and this is basically the same display we have. So we know here why we have 128 and 64. Now we can connect it. We use pin 32. That was the same one. We could use other analog inputs. We set the attenuation to 11 dB, which means it gives us the full range between 0 and 3.3 volts, which we want with the voltage divider. And now we are in a loop. We read in the analog value, we print it out, which we see down here. We fill our display with 0. Basically, we clean it, we show that, then we put our string on top, and here we have the conversion to string. Then we show this, then we sleep for 1 second, and we repeat it. And with this, we have a sensor connected to the display, and so you can now use the display also for debugging. Especially, this is especially interesting once we deconnect it from the computer and we can't see the info on the serial line anymore.